Hello AP Statistics students. In this video, we are starting Unit 2, which means we are looking at two variable distributions now. So not just a single variable, but what happens when you have two different variables. And we're going to start with categorical variables. This should mostly be some review. We've done a lot of this before, but hopefully this just will cement what we already know. So our objective here, we will read and make contingency tables for bivariate categorical data. So bivariate. Bi, of course, means two, and variate is a fancy way of saying variable, so two variable categorical data. This will include frequency tables, relative frequency tables, joint relative frequency tables, and conditional relative frequency tables. All right, and then we're going to look at graphs for those as well. So we need some data first. So first off, here is our scenario. The sinking of the Titanic is probably the most famous shipwreck of all time. It sideswiped an iceberg and then took 2 hours and 40 minutes to sink. At the end, it did, I believe, break in half. Sadly, the ship didn't have enough lifeboats, and many of the lifeboats weren't even full because of class discrimination. Let's look at contingency tables to examine who survived this tragedy and what class of ticket they had. So here is a summary table, a frequency table of that data. So each part here tells us what happened. So here we have 118 people survived and were in second class. Here we have 673 people. Those were crew members who did not survive. So that is just a basic summary table of the data to put it in and organize it. Now what can we do with it? There's two types of tables we can make from a frequency table. A relative frequency table, which is simply taking all of these numbers and turning them into percents. The key there is that your total that you're using for those percents is the full total. So the 2,201 in this case. All right, you're dividing everything by the full total. The other type we have are conditional relative frequency tables. That is where you don't use the 2,201. You either use the rows or the column totals to make your percents. All right, so first let's do the joint and then we'll do the conditional. The conditional is definitely the more complicated of the two. So first the joint. How are we going to figure out what these percents are and where they go? So let's start with the people in first class who survived. I'm going to take 203 and divide it by 2,201. So 203 divided by 2,201. And so that moves the decimal point over twice. So 1, 2, that is 0.09, 9.2%. And we come down here, and in our joint relative frequency table, that is 9.2%. Let's check one more. Let's figure out where this 30% comes from. So I go back to my frequency table, and I'm going to take 673 divided by 2,201, and that will give me this joint frequency. So 673 divided by 2,201. Now that spot here, 0.30, that's about 31% or 30.5%. So this number right here would be 30.5%. So if we go down, and yes, they rounded up to a 6, 30.6%. So now what does that mean? Let's choose one of those and interpret. Let's just do that one. That means 30.6% of the people on the Titanic were crew members who did not survive. So 30.6% of people on the Titanic All right, now that part's important. The people on the Titanic, that tells me I am talking about the entire total. The biggest number there is, the 2,201. I'm looking at all the people on the Titanic, and 30.6% of those people were crew members who did not survive. Okay, so that's how you read a joint relative frequency table. Now it has a bonus here. It also gives you marginal distributions. Those are the distributions in the margins. These ones over here and these ones over here. These are the totals. These totals have meaning. So what do they mean? Let's interpret one of those. Let's do this one right here, 67.7%. So because I'm doing a joint sort of still, this is still the entire ship. So 67.7% of people on the Titanic. Remember, I'm still looking at the whole thing. Now, what is true about that 67.7%? Well, that's adding up all of these. And all of those people did not survive. Okay, so that is the joint relative frequency table, probably the more simple one. Let's kick it up a notch and look at the conditional relative frequency tables. Okay, so a conditional relative frequency table, we no longer look at the total, the 2,201. You either look at the rows or the columns, depending on which one you do. And that's the hard part. Which one are you looking at, rows or columns? And so this sentence right here is really important. The distribution of ticket class by survival status. All right, and that is what's going to tell you what to divide by, this part right here, by survival status. That's the number you divide by, is the survival status totals. Okay, so where the heck does this 28.6% come from? We're going to go all the way back to our frequency table. We're going to take 203 and this time divide it by 711. All right, we're dividing it by the survival status. So 203 divided by 711 gives us our 28.5%. And that's where all those numbers come from, by taking what's the frequency inside the table and dividing it by the total at the end of the row. Because we're doing this by survival status, we're dividing it by the total at the end of the row. So that is where all of these numbers came from. We took 118, divided by 711, and that gave us 16.6%, etc., etc., etc. So how can we interpret one of these percentages? Let's go with the 29.8%. What does that mean? 29.8% of, so now I'm not doing the entire Titanic. This is only of the people that survived. 29.8% of the people that survived. So my total has changed there. What do we know about those people? They were crew members. Now, in a little bit, we are going to do this whole thing backwards, because remember, the conditional one that we are doing here is distribution of ticket class by survival status, and you better believe we're going to switch that up here in a second and do the exact opposite. And that will switch my sentence around as well, and these percents will be a bit different. All right, that's how you interpret the table, but what about the pictures for the table? So here are two types of graphs for a conditional relative frequency table. So the one on the left here is a simple bar chart. Okay, we take the percents in the top for all the alives, and we simply graph those percents. And then next to it, you can do the same thing for all the people that did not survive, and those bars are there for these percents. Another thing you can do is you can stack these on top of each other. Over here, we have a segmented bar chart. This is the one that's a little harder to read, but it does have its uses. So the segmented bar chart takes these percents, stacks them on top of each other, and each bar will, of course, have to equal 100% because the left bar here are all the people that survived. So here is the distribution of all the people that survived, and here's the distribution for all the people that didn't. And it has to have a good key over here so you know what each bar and box means. But looking at it, the picture's got to tell us something, right? What does the picture tell us? Well, when I take a look at this, I see that these three bars here, well, they're pretty close to even. That means the distribution in the people that were alive, that survived, of first class, third class, and crew, were pretty close to the same. All right. Oops, let me get me. I'm not sure why my mouse isn't working. There we are. Let's put a description right here. Okay. So the distributions of, the proportions. The proportion of first class, third class, and crew members, if I could spell that word, among survivors. Okay, that's the total I'm looking at. I'm only looking at survivors. We're all about equal. And then I should say something about second class. That was definitely less, right? The proportion of survivors of second class members among the survivors was much less. Let me open that up a bit. There we go. So again, I had to make sure I said that this was only among the survivors. And those three bars are about equal. The proportion of second class members among the survivors was quite a bit less. Now, how do I see that over here in the segmented bar chart? Well, I would have to recognize that this bar, which are my first class members, this bar, which are my third class members, and this bar, my crew members, those are all about the same. And so I could then come to the same conclusion. All right, now let's take a look at the other bar, or the other part of our segmented bar chart. I look at this and I see, wow, these two here are much bigger than these two. So the proportion of crew members and third class members among the people that did not survive was much, much higher than the proportion of first and second class members that did not survive. I'll put that into a sentence as well. Let's see if I can move some of this up a little higher. Period. So the proportion of crew members and third class members among those who did not survive was much larger than first class and second class. I might say even ticket holders. Members is kind of a weird, ticket holders. So you can get the sort of the same idea from both graphs. Again, if I was to get that from the bar chart, I would notice that this bar and this bar are both much, much bigger than these bars. So those are the two pictures you can draw with a conditional relative frequency graph. Okay. Now, I said we were going to do that whole thing backwards, so now we are going to. We are now going to do a conditional relative frequency table of survival status by class. So that means I'm now going to go by the columns. I'm going to use these totals down here for my percent. I know that because it says by class, so I'm going to divide by the class totals. So what is my first number going to be? Well, I'm going to do 203 divided by 325. 203 divided by 325. So that will be 62%. 0.4. All right, let's do the next one here. So the one below that will be 122. So that'll be 122 divided by 325. 37.5%. And the one way to check this is these both going in the columns now should add up to 100% along that way. So all these totals down here need to be 100%, etc. All right, hoping that made some sense, I'll give one more for you. This will be 118 divided by 285. I'd recommend pause the video here, finish filling out this table, make sure you can see how a conditional relative frequency table is made. I will show you the answers here in just a second. All right, hopefully you did that. So down here, if I scroll down, here are all of those answers for the conditional relative frequency table of survival status based on class, by class. Okay, so you can take a look at those percents, make sure you got those right. Now we could again make a graph for this as well. So here is a segmented bar chart of that data. All right, so this is survival status based by class. And so we just take those, the crew members have to add up to 100%, each one has to have up to 100%. So what do we notice here? All right, so in terms of survival status, the first thing I see is the first class are much more likely to survive, and the other three are fairly, I might just go with third and the crew are very much the same. Second class and first class have a lot less not surviving as alive. So I'm going to come up here. I'm basically going to reverse my sentence up here. Where is it? All right. So here I put the proportion of first class, third class, and crew members among survivors. Now I'm going to sort of switch that around. I'm going to say the proportion of survivors among the blank class is the way that sentence is going to be. Okay? So the proportion of, let's do survivors. The proportion of survivors among, what am I looking at here? Third and the among third class and the crew were about equal. And then I'll say the proportion of survivors among first and second class were a lot higher. All right, they had a lot higher proportion of survive. I'm looking at the yellow part here, the orange part. Those were much higher. I might even put in that first class was, of course, the highest. With first class being the highest. All right, so there is kind of how we can take a look at the segmented bar chart. All right, I got one more problem I'd like you to try out to see if you can get this. All right, an administrator at a large university is interested in determining whether the residential status of a student is associated with the level of participation in extracurricular activities. Residential status is categorized as on campus for students living in a university housing and off campus otherwise. A simple random sample of 100 students in the university was taken, and each student was asked the following two questions. Are you on campus or off campus? And how many extracurricular activities do you participate in? Now you might think, hey, whoa, I got you there. That second one, that's not a categorical variable. And you said this was two categorical variables. Well, it gets turned into a categorical variable because they give them three categories: none, one, two, or more. So the number gets put into one of three categories. So yes, it is a categorical variable. So I got two questions here I would like you to try. Which conditional relative frequency is depicted in the segmented bar chart? Blank and blank, all right? Something by something. And then I want you to write a few sentences that summarize what the graph reveals about the association between residential status and participation in extracurricular activities with these 100 students. So write that out and we can talk about that at our next class. Good luck.